Right, good morning. It's the 26th of March. I'm doing another one of these strange vlogs things that I've now started to refer to as, how do I describe this? Yeah, my brain's gone. I've been up all night, I've been working. Bear with me a second. These are my lockdown waffles, where I basically talk at you for a little while, just to get my face out there, and the fact that we're all going to be basically in isolation for a while, and yeah, go on from there. I'm actually going to talk briefly about why I'm doing this. Basically, someone, friend of a friend, pointed out on Facebook recently that if we spend all our time sharing depressing statistics with the current situation, we are going to drive ourselves all mad. And I'm just trying to basically put some stuff out there that's going to give people maybe 5-6 minutes. I know it's not a lot, of like something to distract them, to get their mind off things, to pique their interests in stuff, and with the vague hope of, generating a bit of positivity. I know, so out of character. You'll do my reputation no good. Anyway, moving on. This one is a strange subject. This was an ask by Julian, the assassin of joy that he is. I'm joking. He's a lovely guy. He wanted to know about cool genetic mutations. Thanks, Julian. I'm an engineer. I'm not even a biologist, not let alone a geneticist. I've got friends who have got background in genetics. Ashley, if you're watching this, please close your ears, because you're probably going to cringe to death as I try and deal with this with my terrible, terrible GCSE biology. Right, so we're going to talk about cool genetic mutations. Now, I had a quick glance through at cool genetic mutations with my Google foo, and one popped out, one I actually knew about for quite some time. I didn't know the full details of it, but I thought it was interesting. I'm going to call it cool, and I'm going to talk about it today, because the other ones, stuff like, oh wow, the athlete gene, yeah, boring. I don't play sports. The other one, which is actually particularly one for me, which is the mutation, well, genetic variation, shall we call it, that, for instance, gives red hair, is also responsible for giving some people slightly higher pain threshold when it comes to stinging pain. It is also the reason why we have got pallid skin, cannot go out in the sunlight for fear of turning the colour of, as one friend puts it, a spanked lobster. Thanks, Nim. However, to move on to the subject matter, we're going to talk about tetrachromacy, and if you see me glance up to the left of the screen or right of the screen, I don't know which, but if you see me look up, it's because I'm having to glance at my computer, because I've had to make notes for this one. And I'm hoping this does not turn into an episode of Look Around You, but I'm having to make notes. Thanks, Julian. Thulian. So tetrachromacy, what is it? Tetrachromacy is functional tetrachromacy. Is a mutation of, well, a variation, I should say, of the genes of the human eye, particularly the cone cells, which detect coloured light. And in a functional tetrachromat, I hope I got that word right, it allows them to actually differentiate between more varying hues of colour. So someone might be able to look at a patch of green. To us would be just a simple patch of green, all the same hue. They might actually be able to see variations of that shade, of a shade of green in there that we would not normally see. Most humans are trichromats. We have only 3 cone cells, which pick up a variation of bands, frequency bands of light. At the most simplistically, where they colour the blue at the lowest end of the spectrum, green in the middle, and red at the high end of the spectrum, the three colours. That's a simplification. I believe it's a little more complicated than that, but it's going to do okay for this particular explanation. A functional tetrachromat is a human who has got a fourth cone cell. A fourth cone cell that picks up another band frequency band of light that is different to the other three. In a functional tetrachromat, it's theorized that this actually exists somewhere between the red and the green light frequencies. I'm looking at here we go, back to my notes. Terribly sorry about this. There's also not a lot of understanding about how the human brain would process a fourth actual cone that is operating almost independently to the other three. A lot of our primary visual processing is actually done within the eye itself, with a lot of post-processing that happens in the eye afterwards. Again, oversimplification, but it'll do. And the end result is that we're not entirely sure how the brain deals with that. In the vast majority of cases, a lot of people might be tetrachromatic and have that genetic variation, but they are not true tetrachromats because they can't actually see the variations of colour because it's not functional. Whether that is due to how the brain is processing it, how the eye is processing it, nobody knows. What is actually at the moment theorized is that it's only people born with an XX chromosome will actually get tetrachromacy. There is a study out there that believes that 8% of those with an XY chromosome have the possibility of having functional tetrachromacy. These other studies generally believe somewhere between 15 to 20% of those with the XX chromosome actually have functional tetrachromacy. However, in 20 years study, only one person has ever been found with functional tetrachromacy. Yeah, that's, for me, is incredibly interesting, because one of the things I always quite liked when I was growing up was the fact that you could see pictures of this is how a dog sees, because most animals only have two cones. They only pick up two spectrums of light, so their actual way they see, we can actually see what they see by having a picture. Us regular trichromates, we literally can't see what tetrachromates can see, and that staggers me. That blows my mind. The fact that I cannot see the world as they get to see it, and that's fantastic. That's brilliant, and yeah, it does me a bamboozle. I think that is going to go in for my pretty much my cool genetic mutation talk for today, Julian. I am going to try and share this on both Facebook and YouTube, because I don't believe Julian gets to use Facebook, or doesn't use Facebook, which is absolutely fair enough. Hopefully I've got through this without swearing, and hopefully that's given something to people to think about. Again, I'm new to this, I'm not very good at it. And again, if this is the first face you see this morning, I am very, very sorry. However, that being said, I'm hoping everyone is out there keeping clean and safe. Stay indoors where you can. Wash your hands again. Keep washing your hands. Also, if people have issues, please don't be quiet. Get hold of your friends, get hold of your loved ones. we're all in this together. Try and help out where you can, and you know, keep everyone on the level. We can all pull through this, and you know, we should be good. Yeah, I'm not very good at this. Sorry. So yeah, that's this morning. It's gone on for 10 minutes now. Apparently, I've probably missed things. Ashley is probably going to hit me with a stick for horrendously mangling this explanation, but I think I've tried to do as best as I can. Julian, if you have more questions, I do trains, Julian. I do trains. I'm good at trains, and other engineering stuff. Biology, not so good. Human emotions, not so good. Military history, not bad at. Not bad at. Again, probably will have someone find me and hit me with a stick one day when I talk out of my backside. But you know, I'm always willing to be proved wrong. So hopefully that is good for everyone. I haven't taken up too much time out of your day. Yeah, hopefully your day is going to be good. And that's it from me. Bye.